Welcome back, folks, to the second module in our detailed A320 course. Today we're going to be covering the exterior walkaround. And we get to utilize the walkaround functionality in Microsoft Flight Simulator 2024, which in my opinion is excellent, and it's going to change the way that we sim going forward. Before we begin, let's take a minute to review the standard operating procedures for the exterior inspection. Firstly, we want an overall assessment of the aircraft status. Are there any missing parts or panels? They need to be checked against a configuration deviation list to make sure we can proceed. Secondly, we want to ensure that any of the surfaces on the aircraft match the position relative to what we've seen in the cockpit when we've done our preliminary preparation. Next, we want to ensure there are no leaks throughout the entire length of the aircraft. And fourth, we want to check the status of all essential visible sensors. And the last two are really observing any abnormalities on either the landing gear or the engines. So as we walk up to the aircraft today, we are in Tokyo in a beautiful all Nippon Airways livery. Just a remarkable representation of the aircraft by the Phoenix team here. Now we always start our walk around at the exact same place, and that is the left-hand forward fuselage. And the first thing we check is the condition of the angle of attack probes. Now these probes essentially sense the direction of airflow, and the utility is warning a pilot when they're approaching a stall. Next, we check that the first officers and the captain's static ports are clear of any obstructions. These ports are designed to measure ambient air pressure, and if icing blocks both the pitot tubes and the static ports, then the airspeed indication and the altimeter will freeze in place and the vertical speed indication will show 0. Lastly, at the forward fuselage, we want to check the condition of the avionic equipment vent air inlet valve. This valve essentially circulates and removes air from the avionics bay to maintain temperature. Next, we move to the nose section of the aircraft, where the first thing we check is the condition of the pitot tube. Now the pitot, it almost acts as a flow sensor instrument, and what it does is it measures speed, pressure, and it also helps to gauge altitude. Next, in the nose section, we check the condition of the total air temperature probe, which helps with fuel temperature, guiding anti-ice systems, static air temperature, and it also helps with the Mach number. Interestingly, they are linked to the elements of the ADERU. Next, we check the oxygen overboard for the flight crew oxygen system, which we had happened to switch on the overhead panel during the preliminary checks. The green discharge indicator shows a visual indication of the oxygen system overboard venting. Lastly, we check if all the doors for the oxygen bay, toilet servicing, and the forward avionics compartment are all closed. Next, moving forward, we check that the standby static ports are clear and the radome latches are latched on both the left and the right side. If you were to actually unlatch the radome and lift the cover up, what you'd find is it would contain the localizer antenna and the glide slope antenna. But from the exterior, what we're looking for are cracks, bird strikes, and any visual damage to the nose cone of the aircraft. When we switched on external power in the cockpit, the ground power unit which we just walked past is what provides that external power. If the power door is open, we do make sure that there is a safety tether attached to the power cable. As we approach the nose landing gear, we will check the condition of all of the lights: taxi light, takeoff light, and both turn-off lights. As we have set the parking brake in the preliminary cockpit preparation, we confirm this by checking the park brake indicator light on the nose gear as well. As we make our way from top to bottom, we're going to check that the safety pin has been removed, and we're also going to check the hydraulic lines and electrical wires. We are going to do a general condition check of the nose gear structure before finally making our way down to the wheels and the tire conditions. We're going to also check that the nose wheel chocks are in place. Next, we move to the right-hand forward fuselage where we check the standby static ports and the pitot tubes are clear. We then make sure that the right-hand and aft avionics compartment doors are closed, as well as checking the first officer's and captain's static ports are clear from obstruction. We check the condition of the avionics equipment vent air outlet valve, which is an electronic flap valve that removes air from the avionics bay and expels it outside of the aircraft. Lastly, we check the condition of the DME or distance measuring equipment antenna. Essentially, it's a navigation beacon which, when paired with a VOR beacon, enables the aircraft to measure their position relative to that beacon. Okay, so we crouch here, watch our back and move to the lower center fuselage. And as we do, we pass the VH3 antenna and come to the TCAS antenna, which is the traffic collision avoidance system. We check there's no leaks from the drain mass and move to the next section. Here we're checking the condition of the antennas as well as the anti-collision light and making sure the pack air intakes and outlets are clear. Then, as we call our physio, we turn around and check the forward cargo door is latched and the AOA probe is in good condition. We then move to the right-hand center wing at the wing root. We check that the fuel panel and the yellow hydraulic bay doors are both closed, and then we check the inner tank magnetic fuel is flush and check the condition of slat 1. We then observe engine 2 from the left-hand side. We check the oil fill access door is closed. This is used for engine oil top-up. We then check there's no leak in the drain mast, and we check the fan cowl doors are closed and latched. We now move forward to check the engine inlet and fan blades. We're looking for things like cracks, any debris or obstruction. Moving to engine 2's right-hand side, we check the pylon condition and make sure the start valve handle access door is closed. This is used for ground crew to manually start the engines in conjunction with the pilots in the cockpit. Observing the right-hand wing leading edge, we check the conditions on slats 2, 3, 4 and 5, as well as making sure the refuel coupling is closed. We also make sure that the inner and outer magnetic fuel levels are flush. Pivoting across the wingtip, we check the condition of the nav light, which is green at the right, red at the left, and white on the tail. Moving along the trailing edge of the right-hand wing, we check the fuel ventilation overpressure disc is intact. We then check the static discharges as well as the condition of the control surfaces and the flaps and fairings. So a little bit about flaps and fairings. Flaps increase lift by diverting air around the wing, and it reduces the risk of stalling, especially during takeoff and landing. At lower speeds, the function of the flap track fairings are to reduce drag at higher speeds and enhance the efficiency and performance overall. As we move to the right-hand landing gear, we just check if there are any obstructions in the outlet area of the engine. Okay, so for the right landing gear, we check the safety pin has been removed and the downlock spring is intact. We check the overall structure of the landing gear, and then we look closely to check if there's any leaks from the hydraulic lines, and we check the brakes and the brake wear indicators. Usually the brakes are replaced when the length of the indicator is close to 1 millimeter. We now check the overall wear and tear and the condition of the wheels and tires. This aircraft has a brake fan installed on the wheels, so those will need to be observed as well. I'll tell you what though, it is hard not to sit and stare at the incredible texturing on this aircraft. Lastly, at the wing, we check the condition of the landing gear light. We check the aft drain mast to ensure there's no leaks, and then we move to the right-hand aft fuselage, where we check the cargo door and selector panels are closed. We then also confirm the bulk cargo door is closed before moving to the rear of the aircraft. We check the condition of the outflow valve. Now, the pressurization system on board, it maintains cabin pressure by controlling this valve, It's electronically controlled and adjusts automatically to regulate that pressure. It opens to release the air and it closes to retain the air in the cabin. We also make sure that the toilet service and the flight recorder access doors are both closed. At the tail of the aircraft, we check the static discharges and the condition of the stabilizers, elevator and rudder. Okay, we are now at the APU portion of the aircraft. And we're going to check that the APU exhaust is clear. We're going to check the navigation light condition. Make sure the access doors are all closed and check that the oil cooler air outlet is also clear. We check the drain for leaks and make sure the air intake condition, this is the flap that opens when the APU is switched on, is clear. We then observe the lower fuselage section for any tail strike damage. We check that the potable water service door is intact. Now, potable water is actually stored in a 200-litre water tank on board, and the capacity of the waste tank is 170 litres. Now, as we move down the left-hand aft fuselage, we get a great view of Tokyo Haneda Airport. We need to check the ground hydraulic connection blue and green doors are both closed. We check the condition of the wing root before moving to the left-hand landing gear. Now, just like the right side, we move from top to bottom and we check the safety pin has been removed and the downlock spring is intact. We then check the overall structure of the landing gear before taking a closer look at the hydraulic lines and the brake wear indicators. Moving in all aspects around the wheels and the tires, we check for overall wear and tear, as well as looking at the brake fans, and we finally check the condition of the landing light. Moving along the left wing trailing edge, we check the static discharges as well as the control surface conditions, and we also check the flaps and fairings. Moving towards the leading wing edge, we check the condition of the navigation light as well as the wingtip condition. Moving towards engine 1, we check that the inner and outer cells and the magnetic fuel levels are all flush, as well as the integrity of slats 2, 3, 4 and 5. On the left-hand side of engine 1, we check that the oil fill access door is closed, as well as the fan cowl doors are closed and latched. We make sure that there's no leaks from the drain mask condition before moving towards the front, where we check the engine inlet and the fan blades. Moving to the right hand side, we check the pylon condition as well as the access panel door are closed, and we check that the start valve handle access door is also closed. And that's it for the walk around and this module. Join me for the next one, where we talk about how to read a flight plan and program the flight management system from start to finish in detail. I look forward to seeing you all there. Thank you for the support. Cheers.